Hi students, welcome to another session. Chapter 2 Complex Numbers, Example 2.8. Show that we have two subdivisions. First subdivision 2 plus I root 3 power 10 plus 2 minus I root 3 power 10 is real. So அதுக்கான solution பார்க்கலாம். Here we know one property. If z is real, if and only if z which is equal to z bar. இந்த ப்ராப்பர்ட்டியை தான் நம்ம ப்ரூவ் பண்ண போகிறோம். ஸோ இந்த கொஷினை இசட்னு எடுத்துக்கலாம். 2 plus I root 3 whole to the power 10 plus 2 minus I root 3 whole to the power 10. இப்போ z bar ஃபைண்ட் பண்ண போகிறோம். z bar which is equal to 2 plus I root 3 whole to the power 10 plus 2 minus I root 3 whole to the power 10 whole bar. Here we can use another one property, z1 plus z2 whole bar which is equal to z1 bar plus z2 bar. So we can write 2 plus I root 3 whole to the power 10 whole bar plus 2 minus I root 3 whole to the power 10 whole bar which is equal to, here we can use one more property, z power n whole bar equal to z bar whole to the power n. So we can write 2 plus I root 3 bar whole to the power 10 plus 2 minus I root 3 bar whole to the power 10 which is equal to, conjugate is 2 minus I root 3 whole to the power 10 plus 2 plus I root 3 whole to the power 10. So just compare with the question. 2 minus I root 3 power 10 is in second term. 2 plus I root 3 power 10 is in first term. Nothing is this addition. So which is equal to z. So we find z bar which is equal to z. So as per our property, 2 plus I root 3 whole to the power 10 plus 2 minus I root 3 whole to the power 10 is real. Next, second subdivision. First we can solve this bracket terms. First term is 19 plus 9i by 5 minus 3i. This is numerator by denominator form. So we should bring it as in rectangular form. So 19 plus 9i whole divided by 5 minus 3i into conjugate of denominator is 5 plus 3i by 5 plus 3i which is equal to, we can multiply the numerator first. 19 plus 9i into 5 plus 3i which is equal to, first 19 into 5, 19 into 3i. 19 into 5 is 95 plus 19 into 3 is 57i. Next 9i into 5, 9i into 3i which is 45i plus 27i square. So 95 plus 57 plus 45 as 102i plus 27, I square is minus 1, which is 95 plus 102I minus 27. 95 minus 27 is 68 plus 102I. So our numerator answer is 68 plus 102I whole divided by, next denominator, 5 minus 3I into 5 plus 3I. This is a plus b into a minus b. So a square minus b square, which is equal to 25. 3 square is 9. I square is minus 1. So plus 9. 25 plus 9 is 34. So the denominator is 34. In numerator, we can take 34 as common. So 2 into 34 as 68 plus 3 into 34 as 102. So 2 plus 3I divided by 34. 34 and 34 cancel. So balance 2 plus 3I. This is our answer for first term. Next we can take the second term, 8 plus I by 1 plus 2I into conjugate of denominator is 1 minus 2I by 1 minus 2I. First we can multiply the numerator, 8 plus I into 1 minus 2I. First 8 into 1, 8 into minus 2I. So 8 minus 16I. Next I into 1, I into minus 2I. So plus I minus 2I square. So 8 minus 15I minus 2 into minus 1 as plus 2, which is 10 minus 15I. 10 minus 15I divided by, next denominator, 1 plus 2I into 1 minus 2I. A plus b into a minus b. So a square minus b square. 1 square is 1. 2 square is 4. I square is minus 1. So minus 4. It will become plus 4, which is equal to 5. So the denominator is 5. In numerator, we can take 5 common. 2 minus 3I whole divided by 5. Once again you can check, 5 2s are 10, 5 3s are 15. So now this 5 and 5 cancel. Balance 2 minus 3A. So 2 minus 3A is the answer for second term. Now we can solve our second subdivision easily. First we can take it as z equal to. Here we know the property z is purely imaginary. Z is purely imaginary if and only if z equal to minus z bar. If you solve, you get z bar which is equal to minus z. This result only we want to prove now, which is equal to, for first term we have find our answer as 2 plus 3I whole to the power 15 minus second term 2 minus 3I whole to the power 15. Now this is our z. We have to find now z bar. So 2 plus 3I power 15 minus 2 minus 3I power 15 the whole bar. We know the result is z1 minus Z2 the whole bar, which is equal to Z1 bar minus Z2 bar. So here 2 plus 3i whole to the power 15 bar minus 2 minus 3i whole to the power 15 whole bar. Next, here also we can use one of the property, Z power n whole bar equal to Z bar whole to the power n. So which is equal to 2 plus 3i whole bar power 15 minus 2 minus 3i whole bar whole to the power 15. So Z bar equal to conjugate of 2 plus 3i is 2 minus 3i whole to the power 15 minus conjugate of 2 minus 3i is 2 plus 3i whole to the power 15. Here we just compare with the question Z. First you have the positive term, second one is negative. So take one minus outside. So you got 2 plus 3i whole to the power 15 minus 2 minus 3i whole to the power 15, which is equal to minus this value as Z. So Z bar, which is equal to minus Z. This is the result we want to prove. Therefore 19 plus 9i 5 minus 3i whole to the power 15 minus 8 plus I by 1 plus 2i whole to the power 15 is purely imaginary. Purely imaginary. This is the result we want to prove.